data is information, and there are all sorts of ways that you can display data. But we're going to talk about three ways today. And those three ways are as a table, a graph, and as a mapping diagram. So this table, you've got your x and you have your y values, which also serve as your coordinate points here on the graph or on the coordinate plane. So like you have 2 comma 3, here's the point 2 comma 3. You have 4 comma 7, here's 4 comma 7. You have 6 comma 8, here is 6 comma 8. But then you also have a mapping diagram that shows, well, when x is 2, y is 3. When x is 4, y is 7. When x is 6, y is 8, and so on. And so all three of these are displaying the exact same information. When you see a table too, you can also think of like function machines when you're in elementary school, and they would show input output. So your x is like your input. When you input 2, the output is going to be 3. Okay. So if I gave you these coordinates here, 1 comma 3, 2 comma 4, and 3 comma 5, you could express those as a table. It would look like this: 1, 3, 2, 4, 3, 5. Here is a coordinate plane or on a graph, and then you have here using your mapping system. Now with this information we have what's called domain and ranges, and domain is your x values. So if I'm looking back here, all these are my domain. 1, 2, and 3, that's the domain. Your range is your y values. So if I'm looking back here, my y values are 3, 4, and 5. You can also think of your x values or your domain as like your input, and it's important to realize that your domain or your x values, they cannot repeat. Your range, your y values, which is also like your output, they can repeat. And if you're ever listing the range, you only want to list it once. So for example, let's say that I gave you the equation x squared is equal to y. And we're going to say we've got our chart, and let's say we're going to use -1 and 1 for x. Okay? Well, if x is -1, 1 squared is 1. Actually, you know what? I'm going to change this so that I don't have too many of the same number coming on in here. Let me change that to a 3. Okay? So let's say we have -3 and +3. Okay? -3 squared is 9. 3 squared is 9. My x values can't repeat, because if I plug in -3, I'm just going to keep getting 9. No matter how many times I plug in -3, I'm still going to get 9. So the x's are not going to repeat. The y values, however, can repeat, because it is possible to have different x values get the same y value answer. So if I plug in -3 here, I get 9. If I plug in +3, I also get 9. So the domain here would be -3 and 3, and the range is simply 9. This works. This is possible. Okay? Alright, so more talk about domain and range. If you're given a graph, the domain is all the values that fall. See how my x values fall between here and here? So that's my range. I mean my domain, I'm sorry. My domain is from -1 to 5, and it includes -1 and 5. And the reason we don't want to just say negative, or I'm sorry, let me repeat that, or rephrase that. It goes from +1 to 5, the domain. And the reason we want to say that it includes everything between 1 and 5 is because it could be 1.5, 2.5, 3 3/4. It's all these values, even when it doesn't fall exactly on the line. So we don't want to just say when we're looking at the graph that the domain is just 1, 2, 3, 4, and 5. We want to include all those values. If you're looking at something like this, we only know these values. We don't know if 1.5 is the domain or if 2.5 could be in the domain. We don't know that, so we can only use it based on what we know here. So looking at it here, we do know that it's everything that's in between these. Okay? Now for our range, our y values, that's going to be everything on the y-axis, or everywhere that it falls on the y-axis, and it falls between here and here. So our range is between 3 and 4, and it does include 3 and 4 because our lines are filled in there, or our dots are filled in there. If we're looking at a mapping diagram, again, our domain is all these numbers, so 6, 5, 2, and 1. And our range is -4, -1, and 0. And here's an example of how two different x values can have the same y value. So when x is 5, y is 0. When x is 1, y is 0. And that's okay. That can work. With a table, your domain is 1, 4, and 8, and your range is just 1 and 4. Again, you don't want to repeat. If the range repeats more than one time, you do not want to repeat it. Now, a function is a special type of relation that pairs of each domain exactly with exactly one range. What it means is that it works. So if I look at something, if I look at this, and because I have one x for every y, it doesn't repeat, like I don't have two x's in my domain, then that's okay. That's a function. It works. But I can't have two different x's or two x's and get different y's. Like I can't have 1 equals 1 and 1 equals negative 5. That's not going to work. 1 is just 1. It can't be negative 5 as well. So that means that it is a function if that's the case. And I know that sounds really confusing, so I'll keep going and I think it'll make more sense. Okay. So for example here, when I look at my coordinates, my domain is 3, because remember your points are written x comma y. So my domain is 3, 5, 4, and 3. But we don't want to repeat it, but my range is -2, -1, 0, and 1. Well, this is not a function because I cannot have the same x value repeat more than one time. It's not possible for x to be 3 and y equal -2 as well as 1. That's not possible. It can't happen. Okay, so this is not an example of a function. Here, -4, if x is -4, y is 2. If x is at -8, y is 2. That's okay. They're different x values. They can have the same y value, but they're different x values. If x is 4, y is 1. If x is 5, y is 1. That is okay. So our domain here would be -4, -8, 4, and 5, and the range is 2 and 1. This is an example of a function. Here on this mapping diagram, if x is 4, y is -3. If x is 3, y is -5. If x is 2, can it be both -5 and -4? No, so that means this is not a function. And here, looking at this picture, we have a quadrilateral here, and the domain is that it goes, x is anywhere between -3 and 2. So I'm going to put -3, that looks awful, and the range is from -2 all the way up to 4. So that is our domain and range. Is this an example of a function? No, because if x is equal to 1, y cannot be equal to 2.5, and y cannot be equal to -2. It doesn't work that way. And it's called the vertical line test. If you can draw a vertical line, and if it crosses the function at 2, or the line at 2 different points, then it is not a function. So this is not an example of a function for many different areas. Okay. If you're looking here, and right off the bat I see that if x is 5, x cannot be equal to both 2 and 4, or y cannot be equal to both 2 and 4. So this is not a function.